Bismillah. Today our third lecture about hypothetical components which are not present in our system. So our third lecture about why hypothetical components, assays and oil characterization by Aspen Plus. Why we need to learn how to model hypothetical components, assays, and why do we need oil characterization. So I have this little example that happened in a real life, and essentially it's that real working in pharma industry or pharmaceutical company. Here we are going to convert x into y, and x here we are going to convert x into y, and you are modeling x which is not present in Aspen Plus. That's of course our problem, and you know that x is relatively common, which you can find. Let's say it's polymer, may it not present in database, and roast, let's say y, which is our product, say it's new compound, totally new product to the market, and of course it's not going to present on the Aspen ICs and Aspen Plus. So why could say you think that will maybe I can accuse Aspen ICs because components are present, and let's we have process which we got x and it mix it in the solvent, we still separate it, we get x and solvent separate, and then we get x into this converter or reactor. It may be converted into 95% of products. Here you can actually model these two compounds. Need to know how to model them, and we will learn some tools in which we get to know how we can modeling, how precise they are, and if they can be used. For me, let's some tools for x and for y and spurs. Okay, let's move forward. So this is, we have example of hypos, you know about it, which not present in our database. It's a gasoline, its product through octanes. Actually this is a mixture of plenty of hydrocarbons as well as diesel and coal, which is a solid. So you know coal is not only carbon atoms generally together, we know this is plenty of all other materials, or maybe typically see natural gas, and that varies lots because there are plenty of volatile, we know this mostly methane. But if we wanted to get a gas substance very unique, let's say eventually you are going to want to model your unique natural gas. So that's why we use hypothetical compounds which can be used to model these substances. So either they are new or they are non-standardized products, but still we can work with them. So why do we need the as saved as stated before this? Either because real life happens. Well, not all the processes substance can be present in a database, may they are not 100% reliable. Let's say imagine we choose x, it's present in a database, but hypo see that in a real life, and you see that in the simulation they're not same, they have different boiling points, the freezing points is different, they are eccentric, you calculate it and it's not the same. You got a very, let's say, not precise phase diagram. So what you will want to do is to change individually these characteristics, and that will be, let's say, simulation, and you will get better results. So whatever reason you need your hypos, you need to know how to model. So once again they still be modeled. Now we use assays. So once again I'm going to bring this example on the crude oil. So once again I'm going to bring this example on the crude oil. Typically you should know how, or you don't know Well, let's learn this that when you got a petroleum streams or crude oil, typically you have some gases which are going to boil up in relatively low temperature. Then we got the light naphtha. Some are used for the gasoline, other are used for the other petrochemicals applications. Some ketones and gas oils are present. They have higher boiling points. Some will be used for lubricants, oils, etc., and eventually fuels, oil, or whatever heavy oils you have, you can use them. And finally we got the residual materials, which typically is used for the asphalt or road tar, roofing tar, and so on. So we can model this if we are not given a very precise definition of what's naphtha, what's natural gas, what's fuel oil. Well, this is why we use assays. And why do we need to characterize our oil? Okay, typically we will need data plant, data input. As stated before, typically we give the viscosity and molar weights average data. We are not given the precise 100% composition data, and so on. So this is very useful because with only two data points we will be able to model crude oil. Of course, the more we added the better. Okay, one would may think that we need paraffins for what we are still model them, and of course we can took this is from the internet. These are the typically composition, the flat, let's say example. Once you can get some of the aromatic, they will be present here, and but the problem is, guys, that you will need to know all the aromatic experience and all the naphthalene, all the paraffins, some alkanes. You know that there are plenty of materials that they are not present, still we can model them. Or may you are thinking on, well, may of this is we are composition, but the problem is that you cannot state it, simplify carbon in the component list. You can always state it hydrogen, because you know the, let's say, what to which, as hydrogen and oxygen and carbon dioxide will interact different, so we cannot simplify state our composition value. We need to state individual values, and this is done with characterizations. So once again, you cannot simply state let's model coal and you search for a coal or paraffins. Well, that's not present. You need to use the oil. Same is true for the gasoline. You cannot search for the gasoline. Here you need to state that use a gasoline 87 will have a different composition than the 92 octane gasoline. So you need to state these with petroleum assays and oil characterizations. So what we learned eventually is that we used components or hypocomponents which are present right here. They are having some properties. They are modeled by Aspen plus Aspen ices, which is awesome. Instead of us actually modeling some substance, Aspen ices do this work for us. Well, calculate critical properties, densities, its molecular weights, normal boiling points, and so on. Hopefully you start to get idea of why do we need to know a hypo, how to model them, and how to start working with petroleum says eventually used sometimes oil characterization. Okay, this is our third lecture about hypothetical compounds which are not present in our database.